Bonjour, me llamo Connor.
Me llamo Peter. Today we talk about the calculus, I mean chemical equations and formulas.
A chemical equation is used to describe a chemical reaction, which is a process that produces a chemical change. The chemical formula of a substance or compound consists of the atomic symbols of all the elements and puts them together. When all the chemical formulas are put together, they form a chemical equation. By using the subscripts and coefficients, the law of conservation of mass is upheld because the equation would be balanced. An equation is balanced when there is an equal number of atoms each element on both sides.
A chemical formula consists of the element symbols instead of putting the chemical names down. Take note that chemical names are not necessarily all of the elements' names combined together. Example, H2S equals hydrogen sulfide. Chemical formulas make up a chemical equation. Example, 6CO2 plus 6H2O plus light energy produces C6H12O6. Or no, not, yeah, O6. Yeah. Each part of the chemical equation is a chemical formula.
Describing a chemical equation can describe a chemical reaction. One way to write a chemical equation is using the chemical names and writing the chemical reactants and chemical products. An arrow, called a yield, represents a change in the reaction and separates the reactants and products. When reading a chemical equation, the arrow is read as just the word produces. A chemical equation tells the reactants, products, physical state, and proportion. A chemical equation must be balanced. An equation is balanced when the same number of atoms of each element are on both sides of the arrow. Photosynthesis is a chemical reaction that occurs in plants. 6CO2 plus 6H2O plus light energy produces C6H12O6. Wait, why did you use photosynthesis twice?
Because I don't have time with all this math homework.
Miss Arthur,
according to the law of conservation of mass, the mass of the products must equal the mass of the reactants. This is important because everything.
This is important because if the equation weren't balanced, then that would mean that magically some elements have been created and destroyed, which is impossible. Which means that the law of conservation of mass must be upheld or the world will blow up. I hope you enjoyed the first part of our video. Now we will be moving on to the examples. Hello and welcome to the video, not video portion of our video. I meant example portion of our video. So let's just cut to the chase because I was too lazy to make an intro. Here's an example. Let's just go with something easy like water. Hydrogen plus oxygen produces water, or H2 plus O produces H2O. Now, this is just a basic chemical equation. There's much more difficult ones, and there's also ones that you need to balance, like this one. Fe plus O2 equals Fe2O3. Now on this side, see Fe, there's only one, and here there's two. On this side there's only two oxygens, and on this side there's three. So this is unbalanced. What you need to do is add coefficients, which are numbers like in front of it. So like 3Fe plus 4O2 would be coefficients. So you need to add coefficients to make them equal. So 4 iron plus 3O2 equals 2Fe2O3. Now that means 4 iron. And now this one is special because there's a subscript too. What you need to do, if it has a subscript, multiply the coefficient by the subscript. So 3 times 2 is 6. That's 6 oxygen and 4 iron on this side. 2 times 2 is 4, so that's 4 iron and 2 times 3 is 6, so that's 6 oxygen. So 4 iron, 6 oxygen on this side, and 4 iron, 6 oxygen on this side. So that means it's now balanced. I hope you enjoyed our crappy video. This is coming to you from Crappy Video Productions, and have a crappy day.